We all know AI is changing the world, right? But it's also creating a totally new kind of criminal, one that's way more sophisticated. Today, we're going to break down exactly how attackers are weaponizing artificial intelligence and how it's creating a new kind of terrifying industrial scale of cybercrime.
Okay, just look at this number. $25 million. That's how much was swiped in a single, incredibly bold scam. So how they do it? The attackers used AI to create a hyper-realistic deepfake video of a company's chief financial officer. It was so convincing, an employee was tricked into making a massive wire transfer. This isn't some sci-fi movie plot. This is what's happening right now.
And that brings me to this quote from our source material, which it nails it. Think about that. An automated, intelligent, lock-picking factory. Cybercrime isn't a craft anymore, something done by hand. It's becoming an industrialized process, a factory that just mass produces attacks. This idea is really the key to understanding everything we're about to talk about.
So to really get what this AI lockpicking factory is all about, we're going to break down the attacker's entire assembly line. We're going to look at 3 core problems that every cybercriminal has to solve, and the slick, new AI machinery they're using to do it. First stop on the factory floor, deception. This is the absolute first hurdle for any attacker. Before you can get to the data or the money, you have to fool a real person. You have to make them believe your scam is legit. And, well, AI has completely changed this part of the game. I mean, this slide just shows you everything. On the left, you've got that old school phishing attempt we've all learned to spot a mile away. The bad grammar, the weird greetings. But on the right, that's the new stuff. That's the AI-powered version. It's perfect. Flawless grammar, personalized details. It looks like it came from a real colleague. With generative AI, attackers can now turn these out by the thousands. And the impact of this? It's staggering. Since those powerful generative AI models became easy to access in late 2022, security researchers have seen a more than 4,000% increase in malicious emails. It's not just a small jump, it's like a floodgate just burst open. So the tech that makes this possible is called a generative adversarial network, or GAN. It's actually a pretty cool concept. Just imagine you have 2 AIs competing against each other. One is a generator, and its whole job is to create fakes. The other is a discriminator, and its job is to spot those fakes. They go back and forth, millions of times, getting better and better, until the fakes are so good they're basically impossible to tell from the real thing. That's the engine that's creating those scary good deepfake videos. And this isn't just theory. Look at how it works in the real world. A North Korean group called CryptoCore used a large language model, think something like ChatGPT or Gemini, as both their research assistant and their weapon maker. First, they just asked it where to find crypto wallet data. Then, they had it generate a perfectly convincing phishing email in Spanish for their targets. And finally, deploy. The AI did the homework and built the bomb. Okay, let's move to the next station in our factory. Because, it's not enough to just fool a human. Attackers also have to sneak past all the digital gatekeepers, the antivirus software, the firewalls, the defensive AIs that are designed to protect all of us. So to solve this problem, they use this incredibly clever technique called adversarial examples. They'll take a malicious file, like malware, and they'll make these tiny, tiny changes to it, changes that are completely invisible to you and me. The file still looks normal, it still works like it's supposed to. But here's the genius part. While we can't see those tiny changes, they are specifically designed to confuse the defensive AI models. These little tweaks exploit the AI's blind spots, tricking it into thinking a dangerous file is perfectly safe. It's basically a digital invisibility cloak. And the results are, well, they're pretty dramatic. When attackers use those specialized GANs to generate these kinds of attacks, the success rate just goes through the roof. In fact, some research shows these techniques can knock the detection rates of even advanced security systems down to nearly 0%. The guards are effectively blind. Okay, so the attacker has fooled the person, and they've bypassed the security software. What's the last piece of the puzzle? Well, for the really sophisticated groups, like state-sponsored attackers, it's all about persistence. How do you stay inside a network, totally hidden and in control, for a long, long time, without anyone knowing you're there? This is where a whole new class of AI enters the picture. We've talked about large language models, or LLMs, but now attackers are using small language models, SLMs. Think of these as lean, mean, compact versions.
An LLM is like a megaphone. It's loud, it's powerful, but it's connected to a big cloud service that leaves a trail. An SLM, that's a whisper. It's small enough to run on the attacker's own laptop, which makes it totally private and completely deniable.
And being able to run locally is a huge advantage. There are no API calls to a cloud service for security teams to spot. It makes them perfect for quietly maintaining a fake online persona for months or even years. This is the tech that enables those scalable AI propaganda factories that can run covert influence campaigns pretty much forever.
So, when you put all of these different pieces together, the deception, the evasion, the stealth, you end up with a brand new type of conflict. What we're really seeing here is the start of a true arms race in cyberspace, a battle between offensive AI and defensive AI that's just getting faster and faster. So, let's just quickly recap that AI-powered assembly line. To solve the problem of deceiving people, they use generative AI. To solve the problem of evading security, they use adversarial machine learning. And to solve the problem of staying hidden, they use those small language models. For every problem, there's a specialized AI tool.
And that brings us right back to that central idea of the factory. We've truly moved on from the era of a single person trying to manually pick a lock. Now we're in an era of automated factories that can manufacture millions of perfect, disposable keys. The speed, the scale, and the sheer sophistication of cyber threats have been changed permanently.
So, as this technological arms race keeps accelerating, with both sides building more and more powerful AI, we're left with this one really critical question. In a fight like this, does the advantage always go to the attacker?